Here is review question 4. So I like you to copy the question, pause the video, solve the question, and then look into my suggestions, right? I'm not giving you solutions for these set of questions, but I'm definitely giving you some kind of hint, right? So here question number 4 is, forces of F1 10 newtons and F2 12 newtons are acting at an angle of 60 degrees. Show that the scalar projection of F1 on F2 does not equal the scalar projection of F2 on F1, right? So figure it out and find what are their values, and you'll find that they are not equal. Then explain your answer, why they are not so, okay? Now here is my suggestion. I'm just making a sketch of the two. Let's say this is my force F1, and at 60 degrees to F1 I have force F2. Let's say this is my force F2, right? So this is F2 and this one is F1, and in between we have an angle of 60 degrees. Now what you need to do is show that the scalar projection of F1 on F2, that means when you project F1 on F2, what do you get? You probably get something like this. Do you see that? That is the scalar projection of F1 on F2. So let me call this point as A. And what is the scalar projection of F2 on F1? So the scalar projection of F2 on F1 will be kind of like this, making 90 degrees here. Do you see that? So let me call that point as B. As you can see, they are totally different, right? So the scalar position from O to A is a scalar projection for F1, right? So when you are saying F1 on F2, magnitude, scalar projection, we are trying to find OA. You see that? And when you do scalar projection of F2 on F1, then we are trying to find OB. That magnitude. These are the scalar projections, and as you can see, they are different, right? So you will get a different answer when you apply the formula. The formula for scalar projection is, so let's say if you are doing F1 on F2, right? So that means you have to do dot product of F1 F2 divided by, so it is dot product of F1 and F2 divided by the magnitude of F2, right? This is the first part, and the second part will be equals to, numerator is same, but the denominator is different. That is, when you do F2 on F1, you need to divide by the magnitude of F1, right? That is how their scalar projections are different, correct? So that is how it is. So when you calculate, you'll get, of course, different answers. And I hope you remember when we say F1 dot F2 is what? Or let me complete this part. It will be magnitude of F1 times magnitude of F2 times cosine of angle between them, which is cos of 60 degrees, divided by magnitude of F1, right? So this gets cancelled, right? You get F2 cos theta. And here you'll get F1 cos 60 degrees, right? So you guess it. This answer for you will be, they will cancel out, and you get F2 cos of 60 degrees. And in that case, you should get F1 cos of magnitude, right? F1 magnitude cos of 60 degrees, correct? So now you can see that their dimensions, their values are totally different. They really depend on forces F1 and F2, right? So that is how they are related, right? I hope you get a good picture of this. So it's the ratio of those scalar projections is the same as the ratio of their magnitudes. Thank you.